The Andromeda galaxy revealed to humanity that our universe isn't centered around us. It's proof that Earth isn't the only place with a galaxy. The history of Andromeda shows we might just be a tiny part of something much bigger. Over the past century, we've learned a lot about Andromeda, mostly from studying it from Earth. But with tools like the James Webb Space Telescope, our understanding has shifted. Data from the telescope has surprised everyone, revealing that Andromeda isn't what we thought. Just over a century ago, people saw the Milky Way as a faint band of light in the night sky. They couldn't pick out individual stars because the technology of the time wasn't advanced enough. Some thought the Milky Way was the center of creation where heaven and earth met. Galileo Galilei changed that in the early 17th century. Using his telescope, he saw that the Milky Way was made up of countless stars and celestial objects, not just a blurry band of light. He showed that Earth wasn't at the center of everything, but part of a vast universe. In the 1750s, Thomas Wright proposed that the Milky Way wasn't just a random scattering of stars, but a flat layer of them. He even suggested that our solar system was part of this structure. While this was a step forward, it was still limited by the technology of the time. By the early 19th century, astronomy was advancing rapidly. Edwin Hubble's observations, with the 100-inch Hooker telescope in the 1920s, were groundbreaking. He found that nebulae beyond the Milky Way were actually separate galaxies, each with billions of stars. One of these galaxies was Andromeda, also known as M31. Its observation goes back centuries, with records dating to the 10th century. Persian astronomer Abd al-Rahman al-Sufi described it as a small cloud visible to the naked eye. Andromeda's significance lies in being one of the few galaxies visible without a telescope. It's like a faint cloud in the sky, hinting at something beyond the stars. Telescopic observations in the 17th century provided more detail, paving the way for future study. French astronomer Charles Messier catalogued Andromeda as M31 in 1764, though mistakenly attributing its discovery. Nonetheless, his work put Andromeda on the map, sparking curiosity among astronomers worldwide. In 1864, English astronomer William Huggins made a significant leap in understanding the Andromeda galaxy. His groundbreaking observation of Andromeda's spectrum revealed differences from typical gaseous nebulae, providing deeper insight into Andromeda's true nature. Despite its colossal mass, estimated to be between 1 and 2 trillion times that of our Sun, Andromeda is a cosmic giant residing relatively close to us in space. Scientific research suggests Andromeda is approximately 10 billion years old, making it ancient in cosmic terms. The intriguing hypothesis proposes that Andromeda formed through the merging of several smaller protogalaxies over billions of years, a common occurrence in the cosmos shaping the growth and structure of galaxies. For a considerable period, astronomers believed Andromeda was significantly more massive than our Milky Way. However, recent research has led to a reevaluation, indicating that the masses of these two cosmic giants are much closer than previously thought. The current understanding suggests that if one were on Andromeda looking at Earth, they would see a galaxy just as massive, putting into perspective the colossal size of the Milky Way itself. Andromeda's physical dimensions, agreed upon by astronomers, showcase its vastness, stretching farther than our Milky Way with an impressive diameter of about 220,000 light-years. This revised perspective highlights the complexities of accurately measuring galaxy mass, intricately linked to the distribution and movement of stars, gas, dust, and dark matter within them. One of the most fascinating features of the Andromeda galaxy is its active galactic nucleus. This highly energetic region at the galaxy center is powered by a supermassive black hole. Observations with advanced telescopes, like the Hubble Space Telescope, reveal an interesting phenomenon. The nucleus appears to have 2 points of concentration, indicating 2 distinct regions where intense emissions occur. The brighter concentration, slightly off the true galactic center, houses the estimated supermassive black hole with a mass between 1.1 to 2.3 times 10 to the power of 8 solar masses, weighing approximately 110 to 230 million times as much as our Sun. Supermassive black holes are common in the centers of galaxies, including our Milky Way, and play a crucial role in their evolution and dynamics. When matter such as gas and stars gets too close to these black holes, it forms an accretion disk around them. This disk heats up, emitting intense radiation across various wavelengths, making the active galactic nucleus highly luminous. Observations of the Andromeda galaxy's nucleus reveal a brighter point of concentration near its central supermassive black hole due to unique gravitational interactions with surrounding stars. In the heart of Andromeda, the supermassive black hole exerts immense gravitational pull on surrounding stars, causing them to orbit elliptically. At perihelion, the point of closest approach to the black hole, gravitational forces are strongest, leading stars to move at their highest speeds and bunch up around the black hole. This concentration of stars releases energy in the form of radiation, creating the observed brighter point of concentration in Andromeda's nucleus, offering valuable insights into gravitational dynamics and interactions. Andromeda also boasts an abundance of globular clusters, dense groups of stars orbiting its center, with around 460 of these clusters each containing hundreds of thousands to millions of stars. Andromeda's globular clusters provide insights into its cosmic history and interactions with smaller galaxies. The accumulation of these clusters and stars from smaller galaxies through a process known as galactic cannibalism enriches Andromeda's stellar population. Recent observations suggest Andromeda may be transitioning from a typical spiral galaxy to a relatively rare ring galaxy. Ring galaxies, characterized by circular or elliptical ring-like structures, contain bright young and blue stars in their rings, while their central regions have relatively little luminous matter. This transformation adds to the intrigue surrounding Andromeda's cosmic evolution and highlights the dynamic nature of galaxies in the universe. Pipe ring galaxies, on the other hand, have off-center nuclei, and the rings tend to be more irregular. These ring galaxies are considered rare cosmic gems, with only approximately 1 in 10,000 galaxies classified as such. Astronomers have proposed two main mechanisms for the formation of ring galaxies: through the collision of two or more galaxies, or when a smaller galaxy passes through the center of a larger galaxy, triggering the formation of a ring-like structure. Examples of ring galaxies thought to be formed through galactic collisions include the Cartwheel Galaxy, Galaxy PM 2026-424, and ARP 147, showcasing the intricacies at play in cosmic events. But what's happening now is even more intriguing. Scientists predict that the Milky Way and the Andromeda Galaxy are on a collision course, and will eventually merge to form a new supergalaxy. This colossal event has garnered nicknames like Milkomeda or Milkdromeda worldwide. However playful these names may sound, the consequences of this merger for humanity could be devastating. As the two galaxies approach each other, their immense gravitational forces will cause them to distort each other's shapes, leading to tidal interactions where stars, gas, and dust are pulled between them. The galaxies will begin to overlap, causing mayhem and destruction everywhere. However, this process won't happen all at once. As the galaxies continue to draw closer, their collision initiates the merging process, leading to significant changes in the environment both in space and on Earth. During the merging process, stars, gas clouds, and dust clouds from both galaxies interact and mix together, leading to the formation of new star clusters and structures within the newly merged galaxy. Supermassive black holes at the centers of both galaxies will also merge, forming an even larger black hole at the heart of the newly combined galaxy. This merging process can trigger bursts of star formation. as gas clouds collide and compress, creating new stars and star clusters. While individual stars are unlikely to collide due to the vast distances between them, the gravitational interactions will dramatically alter the structure of both galaxies. The Milky Way and Andromeda will eventually form a giant elliptical galaxy or a new disk galaxy, with the combined mass of their stars, gas, and dark matter. As the two galaxies continue to interact, their supermassive black holes will spiral toward each other, merging into an even more massive black hole at the center of the new galaxy. This merger will release enormous amounts of energy in the form of gravitational waves, rippling through the fabric of spacetime. The combined black hole will dominate the core of the new galaxy, influencing its dynamics and evolution. The merging process will also have significant implications for the solar system and Earth. Although our solar system is not likely to collide with another star, it may be ejected from its current position in the Milky Way and flung into a different orbit within the newly formed galaxy. This shift could alter the conditions for life on Earth, potentially disrupting the stability of our planet's environment. The collision and merger of the Milky Way and Andromeda represent a dynamic and dramatic event in the cosmic timeline, showcasing the ever-changing nature of the universe. This monumental event, set to occur in about 4 billion years, reminds us of the transient nature of cosmic structures and the continuous evolution of galaxies. The study of Andromeda and its future collision with the Milky Way provides invaluable insights into the processes that shape galaxies and the universe as a whole, deepening our understanding of our place in the cosmos.